Hello out there, everybody. Manny here at Area 503. And I hope you all have been well since our last video. Today I just want to talk with you all about some strange footage that a fellow YouTuber by the name of Mayanhausen74 found. They got a channel called UFO Near Sun. And they found some strange footage while observing the Solar Dynamics Observatory. Let's take a look at what they found. Wow, check that craziness out. The moon passes right in front of the sun, and then it pauses for a moment, and then it changes direction. But that can't happen, can it? And if it did happen, there'd be noticeable effects here on Earth, as the oceans and the tides are closely linked to the moon's gravitational pull, right? So what's going on here? Let's go ahead and dig into this just a little bit more. So what exactly is the Solar Dynamics Observatory? Launched in 2010, the SDO is part of a 3-mission study focused on our sun. Along with the Van Allen probes and the Parker Space Probe, SDO comprises the Living with the Star mission currently underway at NASA. Now, normal SDO imagery looks something like this. And you will notice the occasional lunar transit. That's the black shadow that moves across the imagery. And as you can see by this imagery, the SDO is helping scientists understand how our sun works. And back in 2011, the SDO captured this standard lunar transit. And this is what the moon is supposed to look like when it crosses in front of the SDO, at least most of the time. While researching the story, I came across this clip from 2016, which shows a double eclipse. Now this happens when the SDO was rotating around as such that the Earth came in between its view of the sun, and then shortly afterwards the moon came in between its view. Now all this really got me thinking, how does the SDO really stay out there and orbit our planet and keep an eye on the sun? It's got to be a tricky task because our planet is rotating around the sun and the SDO is rotating around us. I think to get to the bottom of this, we really have to understand how the SDO is able to image the sun consistently while orbiting our planet. So here you can see the DSO in orbit above the Earth. It's constantly trying to rotate and keep its instrumentation pointed towards the sun. And all the while it's trying to maintain that velocity, as you can see there in red, so that it can stay in orbit above the planet. Okay, just to summarize, the Earth is rotating around the sun. The DSO is rotating around the Earth. All the while the DSO is trying to manipulate its position so that its sensors stay pointed at the sun. And occasionally the moon is going to eclipse the sun from the SDO's perspective. Now I'm starting to get an idea of what might be happening here. Let's take a look at an example from September 2018. In this clip you see the moon pass from the left to the right, and then back from the right to the left. And when I saw this clip, it instantly reminded me of the clip from 2019. Astronomy Live made a video about the 2018 incident. They did a quite in-depth analysis, and they even created a couple of computer models. Now I'm not going to play the entire piece here, but I am going to summarize it for you. And I'll put a link to the video in the description. In that video, they state that they believe that the effect was caused by something called retrograde motion. And I'll try to make an example here. Retrograde motion is the apparent motion of a planet in a direction opposite to that of other bodies within its system, as observed from a particular vantage point. In this example, the first red dot indicates the SDO. The second red dot indicates the moon. And this line shows the intersection of the moon across the DSO's line of sight. And as you can see here, the orbit of the SDO is lower than the moon. And as we start the animation, you can see that the SDO also travels faster than the moon. But we're also going to see something else kind of strange. As the SDO passes the moon, it rotates to fix its view on the sun, and this makes it appear that the moon changes direction. Let's take a look at the bouncing moon clip once again. Oh boy, that sure is strange. I really don't know why the moon appears to change direction in the SDO imagery. However, it does seem that retrograde motion is the most likely culprit. What do you all think? Let me know and I'll get back to you. Once again, I'd like to give a big thank you to Mayanhausen74 at the YouTube channel UFO Near Sun. They are doing great work over there. If you guys haven't got a chance to, go over and check out the channel. They spend a lot of time watching the SDO and searching for anomalous images and bringing them out to you guys. So head on over and support them. Well guys, that's all I got on the 2019 bouncing moon witnessed on the SDO. I hope you all learned something today. I know I sure did. As always, this has been Manny at Area 503. And I wish you all the best until we meet again. And I am out of here to continue my search for universal truth.